Snow weather. Trained by electrician with overhead wires on the roof, all the way to spark with lightning. Didn't see it clearly, right? Let's slow down the camera. Pay attention to the position of the arrow. Have you ever wondered when you were on the train? How engineers solve the problem of friction and wear between electricians and overhead wires on trains. To clarify this issue, let's first take a general look at the basic structure of modern train electricians. This seemingly simple design, but it is the accumulation of technical experience of generations of engineers. It consists of a rising arm and a falling arm. The bottom half of the electrician is a 4-bar structure. As we rotate, lift the green bar, you'll notice that the yellow one at the tail changes its angle. Then we extend this rod out until the emergency head here. As we go up and down, the emergency head at the end will be cleaned to varying degrees with the change of height. Such a contact surface will cause great wear and tear between the two. To solve this problem, engineers introduce a sense of balance here. He is handed over to this place on the lower arm. There's a little pole up here, connected to the bottom of the emergency head. As we operate the electrician's ascent and descent, it will adjust the tilt angle of the electric head with an opposite force. Keep it at the same parallel angle to the overhead wires at all times. This greatly reduces the wear problem between the two. The base here rotates the shaft wall through this pneumatic piston. You can freely control the rise and fall of the electrician when a train needs to switch tracks. And this figure 8 board on the top does that. The slanted ears on either side assist in smooth switching between the overhead lines. The voltage of the train overhead line is 25,000 volts. Therefore, the base of the electrician, an absolute must be at edge design. Now back to our previous question. How did the engineer solve the wear problem between the two? First, overhead wires. It doesn't extend in a straight line. It's a zigzag pattern. This design avoids the train from running. The wires are always rubbed by the electrician in the same position. This extends the lifespan of the electrician. The next thing to consider is how to reduce the wear of the wires. You can do it by adding a carbon strip to the receiving surface. This principle is similar to the carbon brush of the brush motor. It has good electrical conductivity and softer than metal wire. The wear of the wires is replaced by the wear of the carbon brush strips. Overall, it still doesn't solve the wear problem perfectly. And this problem is left to the future engineers in the comments section to solve.